Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Ikhwan bin Muhammad Zamri, and the title selected for my final year project was Motion Control of Rotary Robotic Arm, that supervised by Prof. IR Dr. Muhammad Azmi bin Ayub. This slide consists of summary of the project, introduction, article review, methodology, and expected result. I will start with the summary. The rotary robot is a crane robot which consists of two joint links. The control system is under-actuated because the movement of the two joints is controlled by a single DC motor. The focus of this project is to move the first joint angle so that the vibration of the second link is suppressed and the energy required to move the link are optimized. For the introduction, robotic arm was first created by George Devol Jr. In 1980s. The robotic arm started to incorporated into assembly line for automobile and other type of industry. A crane robot is built with components such as microcontroller with specific Atmega 328P and motor. The main component of the design is the microcontroller, as it coordinate and control the robot action. This project contains a DC motor, encoder, motor driver, and Arduino Uno. The problem statement: as the rotary robot make a rotation with a certain speed, it will make the second link to rotate a bit due to inertia. In order to make it move smoothly without affecting the second link, the speed must be controlled. Our aim through this project is to understand the principle and theory involved in the various aspects of the robot manipulation. The objective of this project is to propose a controller for moving the load from point to point as well as suppressing load vibration. Next is to control the speed of the robotic arm in order to avoid the movement of the second link due to inertia. And lastly is to determine the energy that required to move the link in the most optimized condition. The scope of work. Testing and experiment will be conducted in the mechatronic lab only. The programming that run the control system must be Arduino software. The rotation will be applied at the first link. Speed control of the rotation of first link will be controlled based on programming on Arduino software. Next is I will continue with the article that has been reviewed, which is about the motion control, open and closed loop control, trajectory planning, trapezoidal profile, vibration suppression, and vibration. Modern industrial machinery design is based on the fascinating automation technology known as motion control. In many applications involving production machinery, motion control can offer increased precision, performance, and efficiency. Open loop systems tend to be more simple and inexpensive. If the planned transfer function is known and there is very little disturbance, a simple open loop controller would be satisfy most design requirements. Closed loop system has the ability to self-correct while open loop doesn't. The controller attempt to eliminate the control mistake caused in the closed loop control by creating the appropriate armature voltage using a voltage source. As for a good path for trajectory planning, 4 conditions must be met. The motion planning technique must always be able to choose the best path under realistic static setting. It must also be adaptable to dynamic environment. It needs to keep helping the chosen self-referencing approach. A minimum level of complexity, data, storage, and processing time is required. And the review about the trapezoidal profile was in order to lessen the vibration which are caused by the resonance of a flexible object being moved by a robot. Research on control algorithm and motion profile must be done. Vibration or oscillation refer to any motion that repeat after a certain amount of time. For a system to vibrate, potential energy must first be converted to kinetic energy, then alternately kinetic energy must be converted to a potential energy. Vibration suppression is the practice of using damping, isolation, or cancellation solution to reduce or eliminate the vibration. If significant vibration frequently happen when the robot is driven quickly, there is undoubtedly vibration caused by the axis twist between the load and the motor. I have provided a flowchart of this project in this methodology section. This flowchart will start with preparation of each part and sketch or drawing the design. After that, continue with research of each part of mechatronics. Design concept is one of the 3 core that affected the progress of this project. If design concept is a success, it will continue with installation and fabrication of mechatronic and mechanical parts. Then proceed to the testing, performance of the system, and write a program. And the second core of the flowchart is run the program. If it is a success, observe the serial monitor and plotting the graph in order to differentiate the performance. As it achieves a good possible performance, then it can be proceed to analyze the result. Lastly, the expected result. There are 5 important criteria that need to be observed, which is the disturbance rejection, which is it will force the link to be in the target position after being disturbed. Second is overshoot. It will be the best if there is no overshoot. Steady state error is one of the crucial criteria as it affected the accuracy. And the peak time, the time that the system reach the target. The faster, the better. Lastly, the settling time with 5% tolerance, where the time reach and vibrate within the upper and lower limit boundary. That's all from me. Thank you.